All right, well, thanks everybody for joining. My name is Mike Raftery. I'm here with SCM Connections, and thanks for joining this webcast. This is a first in a series of webcasts that we're doing, and of course, we'll email out the rest of them along the way. The theme of these webcasts is one that we've had our clients, actually, unfortunately or fortunately, that they have it, our IBP clients deal with a lot, and recently it's managing chaos. Chaos comes in a lot of forms. It could be weather related, could be government related, such as tariffs, which is what we're going to look at today. Could be supplier related, could be findings like a news report or social media. Any of those things can really pop up at any time. And a lot of times people have struggled in the past trying to simulate it, and you end up doing something in Excel with a VLOOKUP, most likely, and emailing spreadsheets back and forth until you find a solution that actually kind of sort of works. And IBP is a great opportunity to actually manage these things and provide some intelligence very quickly around it. So that's what we're going to show today. Again, we're going to show a bunch of these different scenarios in the future over the next month or two. Just a quick bit of housekeeping. It's a webinar, so hopefully I can see everybody online. If you have a question or if you want to ask something, use the chat window, or I think you can raise your hand too, and I'll do my best to answer questions along the way. I do appreciate participation. As far as the agenda and what we're going to cover today, here's what we're going to do. Everybody's here, obviously not to see my amazing PowerPoint skills, but I assume that they want to see how the system works. So I kept the slides very light, and I want to go through just a brief overview of IBP. I can see, some familiar names, some not as familiar names. So I want to make sure everybody's kind of level set on what we're going to show. But I'm not going to go into everything in IBP. That would be hours and hours. What I'm going to focus on is the scenario management. So I'm going to focus on scenarios and what if planning. And I'm going to show a brief overview of what that entails, and then I'm actually going to show how it works in the system, simulating some changes in the supply chain and being able to evaluate actually what that does in real life. So that's what we're going to cover today. Again, the scenario that we're going to look at is around tariffs, actually, how to model that. So it's timely. I'll try not to get political with it, but I'm just going to show how supply chains will react. So first of all, a little bit about ourselves. Thank you for those that are joining for the first time, and welcome back for those that I've seen, whose names I've recognized. SCM Connections, we've been in the supply chain space in one way, shape, or form for quite a while. We have experience throughout the industry, mostly in supply chain. We started out, the partners did anyway, with APO way back in the day. We've kind of evolved quite a bit, and that's what I want to show here is we have our SCM Connections brand, which is what we're going to show today, and that's your people, process, technology. We have an extreme supply chain bend to how we do projects, and that the technology is almost ancillary to the projects that we do. So as you see here, we take technology and make it work for real life situations. And that's what we're going to do today, is show how you actually make this technology work for you. And so our projects focus on that too. We do a lot of blueprinting. We wrap the technology around your process, and then we help you find the ROI out of it. Something new, we're not going to cover today, but in the future we will, is the machine learning application capabilities. And that's a brand that we stood up called Think SCM, where we have a lot of data scientists, heavy-duty analytics to solve basically the most extreme supply chain problems you can find with a series of machine learning applications and data scientists integrated with IBP. So it's a pretty amazing part, and the two combined give us some capabilities that you just won't find in the marketplace anymore. And we're happy to share that with you today. We do a lot of IBP projects lately. We started out doing APO projects, and actually we've changed quite a bit away from doing as many implementations and focusing more on helping people get the ROI back on their projects. So for example, if you have a project that has gone in and it's either not achieving what you're looking for, or how do we actually bake this around the process, that's really what we focus on, and it's been a great advantage for our clients specifically, and more enjoyable for us, to be honest. We're all supply chain nerds that happen to end up in the IT space, so we love solving these complex problems more than we do fighting the configuration. although we will do that. We focus on supply chain people first, so you can actually bring us into a room and have an intelligent conversation about a supply chain problem, go away and make the applications work for you. So again, we are deep in the community, Gartner, APIX, ASOG, IBF, both partners with SAP and SAS, so again, been a while, around for a long time. The company's been in existence for about 6 years. But we've been working in the APO space since 2001 and the IBP space just about since its debuted in 2014. So enough with the sales pitch. What are we going to show today? So this slide here shouldn't be a surprise to anybody that's been exposed to SAP before. This is sort of the classic one. What I wanted to highlight, though, is that IBP itself as an application stands for Integrated Business Planning, and it encompasses a lot more than what we're going to show here. So today we're going to show some of S&OP and some constrained supply planning as well. We're not going to go into demand planning or inventory optimization. That's for another day. What I'd like to show, though, and this slide doesn't do a great job of it, but I'd like to highlight it anyway, is that an IBP implementation done right in a process done correctly, you shouldn't really notice what modules you're running through. It'll just work. And your people will know that they're solving an inventory problem, or that they're looking at a consensus demand plan, or they're looking at scenario planning, but they won't know what module they're in. They won't have to log in and log out. They won't have to really change their perspective, that these applications will just work seamlessly together. And that's what I'm going to show today. So we're going to look at mostly the S&OP evaluation process, including financial implications and simulations. And we're also going to look at specifically the constrained supply chain optimization. So we're actually going to show the optimizer running in real life today. We're going to stay away from order series because, again, this is just for simulation purposes today. So those that haven't seen IBP, what allows for a lot of this, and as I navigate through and do the scenarios and do the master data and transactional data modifications, it's HANA that makes it work. So that's the availability to give me the flexibility and the power I need to actually run these simulations and aggregate it and disaggregate it at any level around the supply chain. It's also, and most significant for this particular functionality, is this end-to-end planning data model, as well as the simulation of the entire supply chain. So it's this area here and this area here. So what that one's going to show me is two things. One, I can go all the way from customer data all the way back to my vendor data, and that's that end-to-end planning model. I'm also going to show you the simulation of the entire supply chain so you can actually evaluate an entire scenario. There's no interface, there's no pass to a different environment. To run a scenario, they're all self-encompassed and they're going to be sitting right next to each other. And that, along with the Excel front end, allows for a lot of power around given to the users, in that they can kind of run any scenario they'd like to, regardless of module or data. It gives the users much more control of their data than they've ever had in previous generations of applications, and enables a lot of this what-if planning that you have today. So next, this one I like to show, and hopefully it appears today, is that nothing will provide more value to your organization than the what-if capability in IBP. To be able to answer these questions, and the questions don't change and the requirements don't change. The difference is that your organization will have the ability to answer these questions in ways, in precise data points that you've never been able to before. So you actually have the discussion not on hypotheticals or I think or it might. You're actually viewing, okay, we have three options. Here is what's going to happen. And it takes the emotion out of it. And that might not sound like too big of a deal, but when you're working with high pressure environments or very sort of contentious scenarios where there's no real good option, taking the emotion out of it and allowing the tool to facilitate a decision rather than people kind of digging in on their beliefs or just, you know, what might happen, is actually going to help do that. IBP is the way that that's going to happen. It also ends up being the translator. So for somebody that's interested in sort of profitability or operational costs or transportation volumes, they're going to see what they care about in their own language. If you care about production capacity, storage capacity, raw material availability, you're going to see that in your own language. If you just want a top line revenue number, you can see that as well in currency. So it allows for any business interest that's out there to actually view what matters to them, even though it's the exact same plan It's like a lens for whoever, for every single person to see what they like. And again, that's the HANA database that allows that to happen. This integration shows up in a few ways. The business units themselves are going to see what they care about. So you're going to see the same solution side by side in dollars in this case, and in eaches or cases. You're going to see customer to vendor maps. You're going to actually view the entire supply chain end-to-end and show how much capital is invested to support it. So the business units are integrated back and forth, and like I said, everybody sees it and is running off of the same game plan. The data integration will allow you to plan at any level. So this says, and you're going to see it here in a minute, you're going to view things at the organizational level, at the yearly level, at the customer level. We're going to have the product location. We're going to go to product family. But that data integration in HANA means that you can actually take any what's called an attribute in IBP or descriptor and manage your entire supply chain at that level. So it's that common platform that allows you to, like on the fly, come up with different reports to different answers. So it allows you in a meeting to say, well, how is that going to work? You know, if you get a question in the meeting where you're trying to solve this problem, you're not guessing, right? You're not, well, we don't have that data cube or you don't have that aggregation level. You know it because you can do it right there. So again, this is not a reporting solution. It's not just an algorithm. It's meant to be a conduit for the planning discussion to have that conducted within the room. And that's critically important as you're trying to, again, avoid the emotion, avoid the guesswork, avoid, well, your spreadsheet doesn't match my spreadsheet, and I don't have your latest update, and this is version 12, how come you don't have version 14? All those sort of things that pop up along the way in these meetings, they go away because the system is the data integration hub. Everybody's making similar decisions off of that same data database. Again, this is sort of a similar view, but I wanted to very distinctly point out that every simulation that we're going to see today, every single one is going to have the customer, the distribution center, possibly a central DC, a plant, and the vendor in every single one. So that simulation is not customer specific, it is not capacity specific, it is not transportation specific. When you create a scenario, when you run a what if plan, when you do a hypothesis, you are seeing the impact across every single node in that supply chain. Okay, that might not seem like a huge deal, but what it allows you to do is to pull revenue out because you have customer level pricing data. It allows you to pull costs out because you have vendor material, raw component and capacity data, and transportation and inventory holding costs. So you're not having to redo those calculations every single time because every simulation has the end-to-end supply chain baked into it. And that's hugely powerful for getting answers in what people really care about, which is profitability, right? I don't think anybody here is in an academic institution where you're just doing this to prove out theories. You're trying to make money. And at the end of the day, it's profitability that should drive these decisions. And to do that, you need the revenue from the customer side, as well as the cost information from the rest of your supply chain to make that educated decision. So that's the IBP Foundation. What if planning allows for two different types of simulation capabilities. So one of them is scenarios, and scenarios are meant for quick hit, hey, how does this look, firefighting sort of decision making. And that's what we're going to focus on today. In this case, our transportation costs are going to change dramatically. How do I model that in my supply chain? That's going to be the scenario. Other things scenarios can be used for are demand swings. So let's say that all of a sudden your product is a YouTube star, good or bad, and that changes your demand. That's going to be a great scenario. Things that you can change quickly, dynamically, things that are time dependent. The key to the scenario is that you're not adding master data to your system. So you're not adding things like locations or products or resources. If you were to add or change master data, that's a great case for a version. And a version is where you're moving massive amounts of your supply chain. A lot of times people use versions for annual budgeting, possible capital projects, what else? New product introductions, mergers, anything that requires a huge amount of master data. So for example, if you want to see, well, what does my supply chain look like you know, if we were to buy a new machine or add capabilities or add a third shift, well, that's a great case for a version, because what you can do is take your master data and actually create that extra resource or create that extra line or create that brand new product family and run that through. But again, a resource, a location, or a product are all new master data elements, and that's what the versions are used for. They're a bit, again, they're a lot easier to use than they were in previous systems, but I'm not going to create new master data today because we only have an hour. I'm going to work with scenarios, and that is your more transactional data. So what is a simulation or a scenario? I'm going to look at these scenarios, and when you do that, you can see, and I'm actually going to go in the system and create these, but you can create as many as you want. So you can do different service level targets I have here. You have different capital improvement projects. These are real time, and they're temporary, and they're user driven. Users can create as many of these as I want. You can see I've created 6 side by side within a couple days here in this situation. And we're going to get into that a lot more in the future. What I'm not going to show as much are these versions. And the versions is, like I said, it's master data. So when you do that, you can actually pick and choose which master data you want to copy between versions. So if you have a version that you use for annual planning or budgeting, and let's say, you know, a new product came in from a ECC or S4, you could actually just bring that one product in. You can filter, you can pick and choose key figures. So you're not recreating the universe every time you create a version or update a version. You're actually migrating it over. The difference being, and this is a configuration setting in your product, or in your project, is which key figures should be version specific and which ones should not be version specific. So you're trying to decide which ones, you know, might mean something different version to version. For example, a resource and a product would be great ones. What would not make sense, maybe like a unit of measure. I can't imagine unit of measures really changing unless you're changing physical properties of things. But anyway, that's part of the project, is to decide which key figures and which master data elements are version specific so you can model those appropriately. So that is the 20-minute version of an introduction to IBP, as well as an introduction to versions and scenarios. From here on out, I'm going to go into our demonstration. So I'm going to show you how easy it is for users to create one. In this scenario, I'm going to be a user. I'm going to show some master data and some collaboration. I'm also going to show the scenarios actually changing. In this case, we're going to change the demand and some of the costs, and then the reporting on top of that. So let's take a look at the scenario that we're going to use today. So today in this scenario, here's how we're actually going to model it. So this is a simple little supply chain that Nikki was nice enough to create for me. Thank you, Nikki. So this one, in this case, we have 3 plants. We have a plant in Paris, a plant in Hong Kong, and a plant in Pittsburgh. And in this case, we're making apparel, shirts for golf, for golf wear. So we went to the international hubs of Paris, Hong Kong, and Pittsburgh to make these garments. And there's resources behind these as well. Our distribution centers, we have one in Madrid that serves our EMEA customers. We have one in Beijing that serves our Asia Pacific customers. And we have one in Charleston that serves our US, or the Americas, US and Canada customers. So as you can see here, our sourcing data is set up so that every distribution center sources their customers. There is no options there. However, we can supply different distribution centers from different plants. So all this data is set up, and I'll show you that data here in a second when I go into the master data workbook. But we have created location sourcing that is flexible. So Pittsburgh, for example, can service Charleston, Beijing, and Madrid, all with different cost parameters. And when we run the optimizer, you're actually going to see it make those choices a bit differently. So in our example, these red lines here are because we're trying to deal with a clothing tariff on imports from into the US. So in this case, anything from Paris and anything from Hong Kong into the Charleston warehouse is going to have extra tariffs on it, so import tariffs. So that's what we have modeled, and I'm going to keep doing a bunch of different scenarios in here. Okay, so I'll keep coming back to this diagram as I can. So if you can see here is the spreadsheet. So this is IBP. Hopefully you can all see it. Anybody tell me if you're having an issue seeing it? Chris or Nikki, my assistants, just making sure you guys can see my screen. Is that right?
Yep, we can see it.
All right, thanks, Nikki. All right, cool. So this is IBP, those that haven't seen it. And my joke is that IBP is incredibly underwhelming when you buy it because it's Excel. If you look, this is Excel. This is my Excel account, 2016. All I have is this little ribbon up here. And the entire application in IBP are these icons. So gone are the SAP days of having to know transaction codes like SAP APO/RRP4 or MMO3 or menu trees or navigation. There's no gray screens. You can do it all up here. So what I've done is I've created I'm going to walk you through my supply chain in the simplest form possible, showing you these scenarios. So in this case, what I've done is I've created one scenario in advance to show you, and then we're going to go ahead and create another scenario as well. So let me walk through a little bit of this, and I'll try and stop along the way and highlight it. So what I've done here, and if you can see my screen, you're going to be viewing the transportation cost. So in this case, I have decided to model my tariffs as the transportation cost. So it's going to cost me extra to bring it into the country. So what I've done is said anything in my ship to, so anything the ship to Americas, okay, from other regions is going to have a extra tariff on it. And so what I did was I have my baseline scenario. So this is my non-tariffed scenario. This is my mainline scenario, is this line right here. And just to show you how easy some of these things are to work with, I'm going to change my view to, because I like seeing rows every time. Again, these are kind of user-specific settings along the way to make it easier to view, but these are the sort of changes the users can do. Anyway, so I'm looking at transportation cost rates, and I'm going my ship to location is America, and I'm coming from Asia Pacific and the EMEA region. And in this case, I've put duties on top. So in this case, I went from $6 per unit to $17 per unit, and in the EMEA one, I went from 5 to 7. I'm actually going to go to 8 because, I don't know, I have some more intelligence that I didn't have before. So when you change this data as well, when I'm changing this, and again, I'll show you how to create this scenario in a moment. If you're changing data within a scenario, it's fairly easy to do. So all I'm going to do is type in 8 in my cell, and because it's Excel, I'm going to drag this across the entire time horizon. Again, this is in weekly buckets. So you can see it's blue, which means it's been changed. I went from $7 to $8 for my tariff scenario from EMEA region to the Americas region. And again, below this is going to be a whole bunch of actual transportation lanes. But one of the benefits with IBP is that you can change the data at an aggregate level and have it disaggregate down. So I went from $7 to $8 for the America to the EMEA region, and I'm going to show you what that looks like behind the scenes because I think it helps demonstrate how easy it is to create these scenarios. So right now I'm doing region to region. I'm going to save this data. Whoops, shoot. No, I do not want to do that. I'm going to simulate it. I have a weird bug that popped up today. There you go. But it doesn't mean anything. So I'm going to save this data here. It offers me a change history if I want. I'm going to say change to $8 from EMEA to Americas. I'm going to save that. And so now it's saving that to the database and all of the values underneath it. And to prove that, what I'm going to do now is I'm going to filter. So I'm going to filter so in this particular view, I'm going to say I want my ship to, so this is how you actually change the data within IBP. So the filters and all of the time buckets and all of the key figures are here. I'm going to show you how I manage the data below. So I'm going to go my ship to location region. I want that to be the Americas. So I'm filtering on that. I'm also going to say my ship from location region. So I'm going to say location region. is going to be EMEA. And I'm going to say OK, and it's actually going to filter down to just those two. Oh, so I did both. OK. So now what I'm going to do with this filter here, or actually with the view, is I'm going to say, well, instead of viewing things at the region level, I want to make sure that it actually worked. So I'm going to go to my ship-to ID and my location ID instead. So now it's the unique identifiers, not the region. And in fact, you know what, I'm going to put region back in just so you can see it. So I'm going to do location region and ship-to region. I'm going to put ship-to region on the top, and then ID, and then location, like that. So again, I'm building my view here on the fly as you're looking at it. What I'm going to show you is the aggregate and then the details below it. So when I do this, it's going to add in the columns for me. And you can see here, my ship to are these America locations underneath, and they actually have the data below it. So it actually blew through all the transportation lanes there, which is nice. What I want to show you next is the master data behind it. So I'm going to say create, and this is how you manage master data. Again, this is going to be version specifics, so we're not going to play with that today. But what I want to show you is how we're going to pick the different locations. So I'm going to pick just one product here. So if I pick one product and if I pick one location, it's going to show you here that I have 3 different options, and all of those options are viable for this optimizer to work with. And that's what comes back to this diagram here. So if I'm looking, for example, at this Madrid distribution center, it's going to have 3 different options to go from Paris or from Hong Kong or from Pittsburgh to Madrid. And that's what that master data is showing here. You can have different lead time indicators. I have different transportation lead times, which shows the duration of the transportation lanes. Again, all that data is built in the system so that the optimizer, when it wants to, it will modify that sourcing along the way. So I have my transportation costs. I also have production costs. And in this case, my production cost didn't change. It's just the transportation costs that change. So if you look, the Pittsburgh plant is producing these products at the most expensive rate. Paris is cheapest, and Hong Kong is the middle of the road. So what the optimizer will also try to do is it'll try and fill up the Paris plants first, and then Hong Kong, and then Pittsburgh, because what it's going to do is be a cost optimization engine. So these are the 2 big costs that we have in our scenarios. And with that, let's get into the scenario bit so I can show you how that actually is set up. So when you look at the scenarios, you can see up here on this ribbon, this is where you manage what you view on the left. This is how you save. Here's your master data in the middle, and then you get to scenarios. And when you have these scenarios here, you can see this is the scenario. You've created, I can promote it, and when you promote a scenario, it means that you're going to bring it to the, you're going to make it live. So for example, if you have a A, B, and the C option, and everybody decides on C, you can promote that scenario and make it live, make that the active. You can reset it and bring it back to the standard baseline scenario, or you can duplicate it. So I'm actually going to duplicate this one, and then I'll create another one as well. So I'm going to duplicate this one, and I'm going to say tariff 2019, and I'm going to say what happens if they increase in 2019. So I'm going to apply those changes, and just like that, I've created a whole nother scenario. Now you can't see it here quite yet, and that's because you have to enable it. So if I go to my view, now you see 3 different scenarios. So these are the 2 I was displaying. I'm going to bring up this 3rd scenario, and I'm going to say OK. And what you'll see here is that as it comes up, there you go. So 2018 now has 3 scenarios. 2019 has 3 scenarios. And that'll propagate throughout the supply chain. So if you look at all the tabs here, for example, if I start to look at, transportation volume, or if I want to look at transportation volumes there. Now I can look 3 scenarios. So every line item here has 3 scenarios. Every data element that I'm looking at, if I want to look at production quantities by location, now because I added that 3rd scenario to my view, I can view side by side by side the impact of those scenarios and what they do to my supply chain. You can view in both, this is a production view. So what I'm viewing here is my production receipts at my 3 production plants. You can see different scenarios that have been run. And you can see the production costs. So how much cost am I incurring in that supply chain? So that's pretty impressive stuff. To be able to actually view it side by side at the detail level and at the summary level. So I'm going to go ahead and change this 3rd scenario. I'm going to simplify this a little bit here. And I'm going to take out the ship to IDs just for the regions. And let's say, just for fun, that in 2019, a new tariff comes in. Let's just say in 2019, let's remove this filter. There you go. So now let's just say in 2019, tariffs have been announced where anything from the Americas into Asia Pacific is now going to have a tariff on it, for example. So if I come out here to 2019 and say, well, it was $4, but they have just announced that anything from America to the Asia Pacific region, again, this is just kind of a high level one, it's going to go from $4 to $12. Okay, whoops, I'm going to change that here. I'm going to change that here. I'm going to keep those the same, actually. I'm just going to change this line item here. So I'm going to drag that across for the duration of the time horizon because it might last for a while. Okay. And I'm going to do a quick simulate to have it populate, and I'm going to push save. And that save is going to, oops, I'm going to save it here. And now it's going to update the database in the background. Now, since IBP is a cloud-based application, it's actually sending this value up to the HANA server that we're connected to and saving those values there, which is also where it's running those algorithms when I run it. It's going to create those actually on the server. So none of this is running on my laptop. So now I have 3 scenarios here. I have the probable tariffs one, and I have sort of a retaliatory one, and we'll see where that goes. So again, this is a cost-based optimizer. It's going to balance out my transportation costs and my production costs and find the lowest overall solution to it. So I'm going to go ahead and run this optimization engine. And we have, this is kind of our specialty here at SCM Connections is optimizers. We made it work many industries, many scenarios. I personally think it's a great value. And for those that haven't seen it, what it does is it looks for every permutation and tries to find the lowest possible cost by moving products around. And we'll see how that works out here in practice in just a minute. But this optimizer, when it runs, I'm actually going to run 3 scenarios at the same time. So I don't have to run them side by side, or sorry, in serial. I can run 3 scenarios all at the same time for this time horizon. So I've clicked my optimizer. I'm going to run this here. Now, when you run an optimizer, it's actually, I mentioned before, trying to find the lowest cost option. And one of the reasons I like this for problem solving like this is that when humans try and solve problems like this, we tend to do a very sort of linear chain of problem solving. So you'll say, well, what if I move this? Okay, that's a little better. Well, then what if I move that? And you end up with a solution, not the best solution. With an optimizer, every time it'll go ahead and actually come at it with a fresh set of eyes, so to speak, and find the total lowest cost solution. Oops. So it's really nice for that way, in that it's going to, it's actually going to try and find the lowest solution overall with a fresh set of eyes. The danger is that it could rebalance your supply chain, so it takes a lot of thorough analysis, but you're not actually coming up with a solution. you're actually letting the algorithm come up with a solution for you and showing you the least cost option for whatever constraints you put in. So in this case, I have a capacity constraint where I have resources, finite resources on the manufacturing side. I do not have any transportation constraints, although you could. It's finished. And I put in cost base to allow it to push one way or the other. So I finished the optimization, and we'll go ahead and review some of these results now. Let's go ahead and first look at some of the production. So, all right, let's see what we have here. So what we have going on is production quantities on top. Sorry, let me come up here. So these production quantities are up here on the top, okay? And the production cost is down below. And the first thing to show is that, well, let's take a look at just these two baseline and probable scenarios. And what you see is that in the difference, the baseline is my standard transportation volumes, and the tariffs are the ones where, in this case, anything into the US has a much higher transportation cost than it did before. And so what did it do? Well, predictably, to avoid those costs, the Pittsburgh plant picked up a whole lot more production quantity, and in baseline it didn't really have any. And the reason why it didn't really have any is because it is the highest cost of production of any of the products. So in this case, you can see, if I scroll down, Pittsburgh, everything at Pittsburgh, just for the sake of my simulation, is $10 a unit, Paris is $2 a unit, and Hong Kong is $6. So that means that it doesn't really want to put anything in the Pittsburgh plant unless it has to. And in this case, when we switch the logic to say, well, all right, it's going to cost a lot more to ship things into the US, then it started filling up the Pittsburgh plant. It also predictably, right, removed production from the Hong Kong plant. So in this case, you can see volumes went from, in this case, 3,000 units to 1,600, 28 to 19, 3,000 to 2,000. So it actually dropped that production fairly significantly. What I'm looking at here too on the graph is you can see the breakout of it. So what I'm looking at is where the production has changed from each week to week. And so you can see the production volumes moving over time. So let's go out into 2019 and see what happened. And again, I just ran this one here live, so I'm kind of doing this. Oh, okay. Sorry, I had a question about which modules are being used. So that's a good point. In this case, the optimizer comes with the supply module. So the supply module has the optimization functions in it. The S&OP module does not. It has just a heuristic in it. So the fact that I did a constraint-based optimization plan means that I'm using the supply optimizer. Again, these tabs along the bottom here are things that I created. So Nikki and I, in about a day or so, created all of these tabs, basically just kind of telling whatever story we wanted to. We said, well, what would people look like? They want to know what the customers are doing. They want to know customer service. They want to know where it's coming from. And we just kind of constructed it. None of these are really module specific. When you buy an IBP module or license it, these algorithms are enabled. So for example, I'm not using the demand planning module because I'm not doing any forecasting in this particular demo. The S&OP operators would have the heuristics come with the S&OP module, and this optimizer comes with the supply module. And then inventory optimization, again, would go with the inventory optimization module. I'm not using that here, so we're not really touching that. But all of the functionality I'm showing you in terms of having things in cost and in units and doing simulations, all of that comes with any module. It's part of the IBP Foundation. It's included in the entire package. So the only thing that is different module by module are these algorithms that are enabled. The rest of it is buy one, you get all of it. Good question. So what we're looking at here, again, is what happens in 2019 when we actually show that the retaliatory tariff, I guess you can call it. Again, trying to stay out of politics, but it's not working. What you come back with is not too much, right? I mean, you see a little bit here where it makes some sense to move production in this week, but when 2019 compared to the standard one means that it really doesn't have a lot of impact on our supply chain. There's a couple of weeks where volume moves to Hong Kong, but overall it's not that big a deal, right? If we look at the transportation volumes, then we can look at, let's just say, well, let's focus on one. So this is all of them. This is all of our supply chain. We're looking at supply and cost, but I'm going to filter down and I'm going to edit my view to say, well, I'm just going to show me the ship to location. I'm going to add ship to, and my ship to location, I just want to see what's going into the Charleston facility. So how is this impacting my US supply chain, basically? And so all I did was put a filter in, and it's going to bring that down and make it a little more digestible. And so what does that look like? Well, predictably, it follows our production plan. So in the baseline scenario, you can say this is what we had aligned to in our 2019 AOP planning cycle. Hong Kong was doing a lot of business for Charleston. In fact, if you look at it, one interesting thing to do that I'm going to show you, and this is something that really helps me out a lot, it's a small thing in IBP that I really enjoy doing, is you can actually change the layout of these things. So I'm going to go in here and say, well, you know what, it's a little hard for me to pick out what's going on. I'm actually going to put the ship to location ahead, and we're going to look at it a little differently. You can also change key figures or scenarios or kind of whatever you want to do. And then I'm also going to do one more. I'm going to say, well, let's take the key figure and put that ahead. Again, these are activities that users can do. So you don't need any IT, you don't need to do any functional specs or design testing or commit to any of these views. All of these key figures themselves are able to be modified in the layout by the user. So, okay, I have one question on optimizers I'll get to in 1 second. Thank you for that. So, transportation supply. So in this case, what I'm looking at here is, here's my transportation supply. It's shipping to my Charleston, DC. All right, and where did it come from? So in this case, you can see it used to come from the Hong Kong facility. Now nothing is coming from the Hong Kong facility at all. Okay, so the tariffs basically shut down all of the shipments. In this case, the transportation supply went from Pittsburgh not even supplying very much to Charleston in the baseline scenario. And now in both scenarios here, you can see Charleston is getting supplied locally by Pittsburgh, and in neither scenario is Paris supplying Charleston. So what does that tell you? That tells you that, okay, well, we had shipping carriers secured in 2018, 2019. If this happens, we don't need that, and we need to start ramping up Pittsburgh plant and finding carriers to go between Pittsburgh and Charleston. So that's a big, I mean, right there, we ran one optimizer. We came up with the lowest overall cost and showed how that lowest overall cost impacted our supply chain right here. I mean, you can see it right now. So if this actually happens, you're going to have to change sourcing, and you're going to have to modify your carriers, right? Those are real world impacts we saw here in about a minute. Again, we just modeled the retaliatory tariffs for 2019, no change. You can say, okay, that one actually doesn't impact us at all. Moving on. These are the sort of things that you can go from the hypothetical to the real life, okay? I'm also going to show you how to summarize these costs as well. I had one question on order series versus time series, which is a good one. So it's on the optimization. So the optimization, so the question was, time series optimization enables calculations like transportation costs, et cetera. For order series simulations, what are some changes that can be done? Order series is a little bit different. Again, this is another webcast I need to schedule. For those that have come from the APO world, where order series and time series are one concept, when you pull them apart in IBP, it's a completely different scenario. And the short answer is that the order series is much more around, you have a constrained, you have a constrained set of either time on a resource or your constrained set of supply. For the sake of this example, just say you have some constrained supply, and how are you going to deploy that most efficiently? In my experience, the order series in IBP is very short term. So that would be more like a natural disaster. And I think we can show some of those in later webcasts to say, okay, we just had, we'll take the forest fires in California. We have a warehouse that's cut off. How are we going to respond to that? That's where order series will come in and say, all right, we're going to shut off that as an option. And how do we actually redeploy inventory most efficiently? So order series is much more reactionary, and that's why it's in what's called the response module of IBP, because you're responding to it. This IBP time series module is much more your strategic S&OP decision making. So you're trying to figure out what should we do in the future, again, on that monthly cadence, where response is like, what do we do tomorrow? One of our consultants was fighting an issue for about 2 months where they had a warehouse completely burned to the ground with all the inventory in it for one of their larger markets. That's a great response module. You would also need this to know when are we going to recover from that disaster, but response will show you what am I going to do tomorrow. This will show you what am I going to do next month and next quarter. Good question. There is a optimizer that's starting in that response module, but it's not as robust as this one, which is more on par with an S&P optimizer. So real quick, to show you sort of, this is the big one, right? So this is where you want to say, all right, that's all well and good. What did it actually do to our profits? So if you look at what happened here, right, you have, well, what did we actually spend? So in this case, you're looking at, here's my revenue. So the nice thing here is that you're showing no customer impact whatsoever, which is nice, right? The shipping costs actually went down in 2019, which is an interesting solution, but your production costs went way up. So what it did was, and you kind of interpolate this from the optimized results, is it said, look, we're actually going to incur the higher production costs to avoid shipping costs, and that's what it did. So the total cost of shipping and production in baseline was $2,018,000. In this probable one, it's 2.12 million, and in the 2019, it's 2.12 million, roughly the same, spreading them around. So what it's showing you is that in this case, you're actually not, your profitability goes down, in this case, what, $110,000 in 2019. So you can actually show not just what are we going to do, all right? So let's rewind a minute. You're looking at, all right, what are these tariffs going to do, right? People are panicking. As a supply chain planner, you would go in, modify your transportation costs in however many scenarios that you want to create, right? Look at your production summary. What did that do to my production? And more importantly, what did it do to my capacity? So we didn't really look at capacity yet, but it's also showing you how it loaded these lines. Okay, so for example, Pittsburgh went from basically 0% utilized for the year up to 10% utilized for the year. So then you got to make a decision, or is that worth turning the plant on or not? Is that worth turning the line on or not for 10 million? And you can actually turn that off and see what happens too. And if I get a minute, I'll do that. But so you went in, you changed your transportation costs, you ran 3 scenarios side by side. You went to your customer service. So this is showing you all your demand shortfalls, which are the exact same across all scenarios. So if I put in here in my chart, I'm going to say, let's do these 3 scenarios. And I'm going to show customer demand shortfall. And I'm going to show them, again, this is Excel, right? So this isn't anything any user can't do, showing them side by side. In this case, your customer service is identical. So you've absorbed these tariffs. You've realigned your supply chain to move shipping from Hong Kong to Charleston, to Pittsburgh to Charleston. And then you've created this profitability analysis. Say, what is that going to do to our bottom line, which is what people really care about? And you can say, well, it's about 10% less, right? So you can say, let's see, equals that divided by that, right? Whoops, I went the wrong way with that. Equals that divided by that, All right, so just a couple % off, not a big deal, maybe. So those are the kind of calculations that you can do because this thing is in Excel. So let's just do, again, this is me kind of pushing it a little bit. I'm going to take this, create one more scenario. So I'm going to go manage, and I'm going to duplicate this guy and say, so this is going to be no Pittsburgh tariffs, no US prod. So I'm going to say, look, I know that it moved production to Pittsburgh, but I can't turn the plant on for 10% capacity. That's nowhere near efficient. So let's go ahead and edit this. So I'm going to say, well, what does that really do, right? So I'm going to say, let's take that out. Let's take, put this one in, take that one out, and take this one out. Okay. So now I'm managing my scenarios. Oops. So now I'm going to say what happens if we just have no capacity at the Pittsburgh facility. So no US production. What I'm going to do here is delete the capacity and rerun it. Delete, save, save. Just make sure it saves. Oops, didn't save. So what I'm trying to do here then, I mean, you can see there's probably everybody has in their own mind, well, how would I handle it and what would I do and what sort of things do people ask in my organization next? That's all this is meant to do. And again, we've done this entire thing plus a PowerPoint presentation in an hour and come up with 4 different scenarios. So this is really what I meant by this is going to drive the meeting. Okay, this should drive exactly what you're trying to do and have that discussion within that meeting itself. So let's do here. I'm going to run them both again. All right, I'll go ahead and run that. And we'll see where that comes out. So while that's running, I want to show one other feature real quick. This is the supply network diagram version. Again, it kind of can show you if people are looking at a larger supply chain. In this case, I've filtered down on one product to say what are the volumes running through this network. You can show it right here. Here's the supply and receipts for this product at this location. You can do inventory. Here's my customer. Here's my, what is this here? This is my production plant. Here's the production resource. So this is the production receipt on this specific resource. So you can actually work your way through, again, in the meeting to view your supply chain in a graphical form. This is part of the web front end that also comes with every module within IBP. So coming back here, let's take a look at my status. Okay, done. See what happened. Okay, in this case, it actually did not change very much. So let's take a look at what it did. So in this case, it came with basically not much. It filled up the Hong Kong plant and it filled up the Paris plant. And let's see if it sacrificed any of the customer scenarios. All right, so if I put these guys in, you can see what it did there. So it actually didn't sacrifice any of the customers. It did most likely go below safety stock targets in some of these locations, which it did. Yeah, you can see here the projected stock is very small here. So the question is, we can shut the Pittsburgh plant off. However, we are going to be really tight on inventory in the Beijing location and in the Charleston location. And what I'm looking at here is the projected stock row against the inventory target or safety stock row. And you can see in absolutely every DC, it is not a pretty sight, right? So this is, again, yeah, we can take that Pittsburgh plant down, but we're going to need some other answer because our safety stock targets are nowhere near where they should be, right? And so you start working your way through that equation. Really interesting stuff, really powerful. We went through 4 scenarios in about a half an hour, all with dramatically different results. And this is the power of what IBP does. As a supply chain nerd, which I am, and I'll admit to, I mean, this is the fun stuff. I like creating these problems and seeing how the optimizer handles them all. And you can see that, the transportation volumes are here and all that kind of stuff too. But what it's really looking for is how are we to put this in terms that people can align on and understand, and that's in dollars and cents every single time. So what I want to do here in the last minute is just to kind of show this is the type of thing that we really find helpful. One concept that we really get excited for, and again, this is for more healthcare industry especially, is okay, let's figure out how much chaos we can handle before our supply chain breaks. So again, this is a little different than what I was coming up with. I was saying, well, what does our tariffs look like? This is to say, how do you actually know what happens if we lose a plant? What happens if hurricane season is as bad as it might be? These are the type of things that you get asked for. We call it stress testing your supply chain. So for example, if you had a lot of pharmaceutical manufacturing in Puerto Rico, which is I think what you're working in, right? How bad is it really going to get if hurricanes come this year? How bad is it really going to get if wildfires take out our distribution center? We kind of worked in the pharma industry for a long time, and that, especially with some critical elements there, whether it's IV fluids or insulin or whatever, those are really questions that you get, is how bad does it get before it gets really bad? And that's what we're going to show in the next webinar, is how do you stress test your supply chain with IBP to get results that you couldn't otherwise. So I think that's it. We're right at time. I appreciate everybody hanging in there. Again, come check us out at scmconnections.com. We have our blogs, our webinars. Reach out to us as well. Again, my name is Mike Raftery. I'm at mike.raftery@scmconnections.com. I'll be emailing out this recording as well. If you want to see more from us, if you really like what you saw, if you have a specific scenario or a specific item that you really want us to look at for you or address, or how would that handle, then we would love to talk to you. So feel free to reach out. We're easy to work with, easy to talk to. And thanks again, and everybody enjoy the rest of your day. Thanks.